All right, let's get right into it. If you've got a Java technical interview coming up on your calendar, you are in the perfect spot. We are about to crack open the absolute core concepts you've got to know to walk into that room feeling ready to go. And hey, if you're feeling a little nervous, that's totally normal, right? Technical interviews can feel like this massive, high pressure test where you have to spit out everything you know perfectly. But that's what we're here to fix. The plan is simple. We're going to spend the next few minutes building up a rock-solid foundation. We're going to take all that nervous energy and flip it into the kind of real confidence that interviewers notice right away. So first things first, we have to start at the very beginning. What actually makes Java, well, Java? What's the secret sauce, the engine that really drives this whole language? I bet you've heard this phrase a million times. Write once, run anywhere. Look, this isn't just some catchy marketing slogan. It's the absolute central promise of Java. It means you, as a developer, can write your code on your laptop, and that exact same code can run on a Windows machine, a Linux server, you name it, without you changing a single thing. So how? How in the world does Java actually pull that off? How can one piece of code just work across so many different systems? Honestly, it feels like magic, but it's really just a brilliant piece of engineering. And the secret ingredient is this thing called the Java Virtual Machine, or JVM. The best way to think about the JVM is like a universal translator. It's a special program that sits between your code and the actual operating system, creating this perfect, consistent world for your Java code to live in. No matter what the underlying machine is, the JVM makes it look the same to your code. And here's exactly how that process works. It's a three-step dance. First, you write your code, the human-readable stuff. Then, the Java compiler takes that code and turns it into something called bytecode. Now, this is the key. It's not machine code for one specific computer. It's a neutral, intermediate language. And that bytecode is the file you can send anywhere, because any machine with the JVM knows exactly how to read and run it. That's the whole trick. Okay, so we know how Java runs anywhere. Now let's talk about what we're actually building. And this brings us to probably the most fundamental idea in all of Java: classes and objects. The best analogy here? Think blueprints and buildings. So a class is the blueprint. It's the design. It defines all the properties and abilities of something, but it's not the thing itself, right? A blueprint for a car says it'll have 4 wheels, an engine, and it can accelerate, but you can't drive a blueprint. The object, on the other hand, that's the actual car that just rolled off the assembly line. It's a real thing created from that blueprint. It has a specific state, its color is blue, its current speed is 50 miles per hour, and it can actually do the things defined in the class, like accelerate and brake. This slide really just lays it all out, plain and simple. The class is the abstract idea, the template. The object is the concrete thing, the instance that you're actually using in your program. You design one car class, but you can create thousands, even millions of unique car objects from it. Okay, so we've got our building blocks. Now, how do we put them together to build something that's strong, easy to maintain, and powerful? Well, that's where the design principles of object-oriented programming, or OOP, come into play. These are like the architectural rules for building great software. Our first pillar is encapsulation. This is all about bundling your data and the methods that work on that data together, kind of like a protective capsule. Think about driving a car. You use the steering wheel and the pedals, the public interface, to make it go. You don't just reach into the engine and start messing with the pistons directly. The engine is private, protected. That's encapsulation. So why does this matter so much? It's all about flexibility. It means the car company can totally redesign the engine, maybe swap it out for an electric motor. But as long as the steering wheel and pedals work the same way, you, the driver, don't have to change a thing. Your code doesn't break. Next up, we have inheritance. This is a huge one for code reusability. It lets you create a new class that's a more specific version of an existing class. For example, you could have a general vehicle class. Then you can create a car class and a truck class that both inherit from vehicle. They automatically get all the basic vehicle stuff, and then you just add what makes them special. Pillar number 3 has a bit of a fancy name: polymorphism. It literally means many forms, and it's a super powerful idea. It lets you treat different objects in a similar way. So you could have a list of vehicles, and in that list, you have some cars and some trucks. When you tell each one to move, the car will respond by driving down the road, and the truck will respond by hauling a heavy load. Same instruction, different behaviors. Now, a classic interview question related to this is the difference between overloading and overriding. It's simple when you see it laid out. Overloading is when you have methods with the same name in the same class, but they take different inputs. Overriding is when a child class provides its own specific version of a method it got from its parent.
And our last pillar is abstraction. This is all about hiding complexity. When you hit the brakes in your car, you just push the pedal. You don't need to know about the hydraulic fluid, the calipers, or the brake pads. You're given a simple interface, the pedal, that hides all that complicated stuff. That's abstraction. It makes things so much easier to use.
Phew. All right, that was a lightning tour of the absolute essentials. So let's just boil this all down. What are the key takeaways you really need to have locked in for that interview? You just need to remember these 7 things. The JVM, that's your run anywhere magic. A class is the blueprint. An object is the real deal built from it. And then you have your 4 design pillars. Encapsulation protects your data, inheritance lets you reuse code, polymorphism gives you flexibility, and abstraction hides the mess. If you can explain these concepts clearly, you're in fantastic shape. Because understanding the tools, that's just step 1. The real fun, the most exciting part, is using them to go out and build something incredible. Now go ace that interview. You've got this.